The Greek word for cancer is karkinos, meaning crab, as sometimes cancer in the body can look like a crab in the sand. The word onkos, meaning load or mass, is also Greek and is used in the word oncology, which means the study of cancer. The first mentioning of cancer is in an Egyptian scroll around 3000 BC. In this scroll, cancer is said to feel like a ball of wrappings and that there is no cure. The next significant writing on cancer was done by the Greeks, who were experts with water and so thought about systems in the form of fluids. They thought that the body was composed of 4 liquids, which they called humors: blood, yellow bile, phlegm, and black bile. When someone was well, all fluids were balanced. Sickness came from an excess of one humor. The Greeks thought that cancer was caused by too much black bile, which had become stuck together to form the mass of cancer. Since black bile is a fluid, it is hard to treat surgically, and doctors were advised not to operate, as it would grow back. So, instead of surgery, treatments contained things like rasped ivory, crab's eyes, fox lungs, crow's feet, tortoise liver, goat's dung, laxatives, tincture of lead, and boar's tooth. The next step forward in the history of cancer happened in the 16th century with a revolution in medicine. Andreas Vesalius, a medical student from Brussels, created the first extremely detailed map of the body. During this exercise, he could not find any black bile. After a few other breakthroughs in medicine, the treatment of cancer moved towards surgery. The first breakthrough was a way to stop the surgical site from becoming infected, which would lead quickly to death via sepsis. Joseph Lister, a surgeon, observed that a waste treatment company near him would treat sewage with a liquid containing carboxylic acid. He thought about treating the site of surgery with this same liquid, and it worked to stop infection, meaning that people were more likely to survive surgery. The next groundbreaking invention was that of anesthesia, an agent which, when inhaled, allows people to remain unconscious during surgery, allowing longer surgeries to take place. Surgeons like Halsted, a surgeon who invented the radical mastectomy, a surgery which tries to take the cancer out by its roots by removing large sections of the body that surround the cancer, could now proceed unhindered by infection or pain. The next great discovery, which impacted cancer therapy, was the discovery of X-rays. Certain materials, like radium, naturally emit rays which are strong enough to pass through the human body. In 1896, Emil Grube, a medical student who had worked in a factory which made X-ray tubes, encountered factory workers with injuries on their hands that were caused by X-rays. He thought he would try shooting X-rays into tumors to see if he could injure the tumor in the same way. Tumors shrank. People got better. Doctors stitched radium directly into tumors. This helped, just like surgery, to remove the tumors. But there was another side to cancer, which, up to this point, had escaped doctors and affected their ability to cure it. In addition to mutated cells being located in a single location, these cells can break off and drift around the body, escaping both surgery and targeted X-rays. How to chase down these cells which break off would take its origin from the cotton industry. Historically, dye to color cloth came from natural sources, like plants, but with a large increase in textile production, a new push to make synthetic dyes formed a field called practical chemistry. By the 1860s, colors which spanned the spectrum were made. Paul Ulrich, a medical student, had the idea to try staining tissue with dyes to help with microscopy. He found that dyes stained one part of the cell and not the other. One night on a train, Ulrich had the idea that artificial substances like these dyes could, like a key into a lock, target one part of the body and not the other. Thus was born the concept of chemotherapy. The war pushed all the chemists from the dye factories into the weapons factories. One such chemical weapon made in these factories was mustard gas. Mustard gas was used in the war and caused burning of the skin, but two doctors, Goodman and Gilman, upon learning that it also selectively killed white blood cells, used this chemical in small doses as a means of chemotherapy. In the past 50 years, over $200 billion have been raised for cancer research, and yet there has only been a 5% decrease in the cancer death rate between 1950 and 2005. In contrast, the death rate for heart disease dropped 64% in that time, and for flu and pneumonia, it fell 58%. There is more work to be done, and more history to be written.